Alright, Christina, these completing the square problems are always pretty tricky. So I'll walk you through this one and hopefully it'll help. One of the keys to completing the square is, the first term here, the A term, this number here is called A, this one's B, and this one's C, of course. The A, when you're completing the square, needs to be 1. You have a 2 here. So what you actually have to do is you have to start this problem by dividing through by 2. Of course, anything you do to one piece of the equation, you have to do to everything in the equation. So we're dividing everything in this equation by 2. The reason we do that is because now 2 divided by 2 is 1, and you just have a regular old x squared out in front. That leaves you, unfortunately, with some fractions in the problem, which make this kind of hard, but hopefully we can figure it out. 0 divided by 2 is just 0. 0 divided by anything is just 0. So the rule with completing the square is you take whatever the b term is, in this case that's negative 3/2, and you divide that by 2. And if you remember about division of fractions, you can actually call this 2 a 2 over 1. You may know how to do this just fine, but I'll do it just in case. When you're dividing fractions, you flip the denominator, you flip the bottom fraction, I should say. And instead of a 2, it's going to be a 1/2, and you multiply. So you have negative 3 times 1 in the numerator, and you have 2 times 2 in the denominator. So that was b over 2. This b term, we divided it by 2. But then what you have to do is you actually have to take that b divided by 2 that we got, and you have to square it. So if you square that, the way to square a fraction is you square the numerator and you square the denominator separately. Negative 3 squared becomes a positive 9, and 4 squared becomes 16. So you have 9 over 16, and that is what they're going to call b over 2 squared. You take that number, that b over 2 squared, and we're just going to add it to both sides of this equation. We're going to take this number that we got, and we're going to copy down this equation pretty much the same as it was before. I'm going to leave a little bit of space. And we're going to take that and we're going to add it to both sides of the equation. So we're going to do plus 9 over 16 and plus 9 over 16. Of course, if you add something to one side of the equation, you have to add it to the other side. So that's why we do it to both sides. Now, the whole point of this, the whole point of this completing the square business is that these first 3 terms that I've written down in parentheses, this is the A term, the B term, and then this new thing that you came up with. We call it b over 2 squared. This thing right here is actually a perfect square, meaning you can take those 3 terms, that trinomial, and you can rewrite it as 2 terms. In this case, it's going to be x plus or minus some number. Well, how do you know what that number is? Well, as it turns out, the number that goes right here inside this perfect square is this b over 2 that we got earlier. So it's negative 3/4. So we have minus 3/4. As it turns out, this thing in parentheses, this trinomial, is exactly this perfect square here, and you can actually check that if you want by foiling this perfect square back out. I'll talk you through it in a second. But I'm going to copy down the rest of the equation because we're not finished yet. We still have this negative 17/2 here, and 0 plus 9 over 16, of course, is just 9 over 16. Now, if you want to convince yourself that this equation in the bottom line here is the same as the equation in the line above it, all you'd have to do is FOIL out this perfect square. And obviously when you do that, your first 2 terms are going to give you x squared. And your last 2 terms are going to give you negative 3/4 times negative 3/4, which we actually said earlier was 9/16. This middle term is going to come from a combination of the the outer and the inner terms when you're foiling or when you're distributing. And you can check that out for yourself if you want. So when you're using this completing the square technique for solving an equation, and again, this is just one of many techniques that we can use to solve these equations. You've also probably learned by now about the quadratic formula, or if you haven't, you will soon. You can always use that as well. This is just one of many techniques for solving a quadratic. But whenever you're using this technique, what you want to do is you want to get x by itself. So the first thing to do when trying to get this x here by itself is you want to add 17 halves to both sides of the equation, because then you're leaving this x minus 3/4 squared all alone on the left side of the equation. 17 halves cancel, and we need to do the addition here. It's 9/16 plus 17 halves. To do addition of fractions, you need a common denominator. So that common denominator is going to be 16. So 17 halves you're going to turn into something that has a denominator of 16 by multiplying by 8. Hopefully you know how to do this already, so I'm doing it kind of quickly on the side here. See, that's going to be, I think, unless I've made a mistake, I hope I haven't, that should be 17 halves is the same as 136/16. So this right-hand side is 9/16 plus 136/16. I should have gotten my calculator out. This is 145/16, I hope. And on the left side of the equation, we haven't done anything. Now, again, when completing the square, the next step in the solution is, again, we're trying to get this x by itself. So the next step is going to be to take a square root of both sides. Now, what I know about the left-hand side of the equation is the square root and the square cancel each other out. That's why we did it. So the left-hand side of the equation, we're just going to be left with x minus 3/4. So we're getting closer to getting x all by itself here. On the right side of the equation, all we have to do is actually take the square root. I don't know what the square root of 145 is. If it can be simplified, I'll just let you do that on your own. But I do know that the square root of 16 is 4. So the right-hand side of the equation is basically going to look like that, unless the square root of 145 can be simplified into something. Then the final answer we're going to get by just adding 3/4 to both sides of the equation. I'm sorry, I left out a little detail here. Whenever you take the square root of something, you actually want to do the positive and negative square root of something. So we are actually going to have a plus and a minus on that term right there. Almost forgot about it. But as I was saying, to get x by itself here, we need to add 3/4 to both sides of the equation. And we're going to get x equals 3/4, positive 3/4, plus and minus square root of 145/4. Again, you might have to simplify the square root of 145. I'd probably whip out a calculator or do a little factor tree over here to decide if that could be simplified. But essentially, that is your answer. I hope that helps you out.